Okay, good day and welcome everyone with the third and the final video, or the third or final lab for the Ccna 20301 Mega Lab series. This is an extra, or we can call it like a Ccna Plus series that was created after the full completion of the English completed or the English complete Ccna 20301 course that was already published in the channel. The channel is III Networking, or as you can see, the title currently is Illimitable Internet Networking International. My name is Sajjad Ghafouri. Once again, from this channel, I'm the only guy that's responsible for the channel. We will not see any other guy for the time being. Okay, and this is the third, as I mentioned, the final lab for this series. This series should be studied and seen after you finish the complete and the complete course that I've already published, which is about 85 videos and 29 hours of studying, practicing, configuring, troubleshooting, and as well as theoretical sides. A ton of theoretical sides you can find in that complete series. This is the time of recording this video is the beginning of June 2020, and so far I have 23 person that have studied my course have passed the exam, the online exam of 20301. Most of them are from the Arabic world, so they are following the Arabic course, which is identical to this TV English course as well. If this is your first time seeing this channel, I hope that you will go to the playlist of the channel, and in the playlist section, you will find 6 courses, 3 courses in Arabic language and 3 courses in English language. You will find the amount of videos are identical for the English course and the Arabic course, for the English Mega Lab and the Arabic Mega Lab, and there is also a third and final series that you will need to study before going to your online exam, which is called the exam preparation, also available in the English language and Arabic language. This series is all about preparing you for this exam itself, what you will find, what you might see, some type of questions that you might see in the exam, practice yourself, how to make use or how to pass and answer more about 100 questions in almost 100 or in 120 minutes. So it's almost like a minute for each question, by counting like some time for becoming nervous, or you need to think a lot of some submitting questions or memorize some informations, or you need to take a rest for a few minutes. Then a lot of skills will be taught in that series. You will find a lot of skills and hints and informations in that series of the example, which is the third series that you should study after you first finish the complete course, which is about 80 to 85 videos, and this Mega Lab series, which is all about implementing and configuring. It's all about, you'll see that only the pack tracer will be there all the way, all the time. And after that, after you study everything theoretically, after you do a lot of labs, this does not mean that only labs are mentioned in this series of 3 videos, and not at all, but in the 85 video series you will find more than 20 or 25 labs regards whatever protocol that Cisco wants you to implement by yourself. Everything: OSPF, static route, DHCP relay, DHCP snooping, NTP, NAT types, dynamic and static. A lot of labs. You'll find them, of course, access list as well, and port security. Yeah. But for extra labs, that is like establishing and emulating real live networking labs, real labs that you will see in the real life, in real environments. This is what's happening in this video. And also some very important protocols that Cisco have removed from the new CCNA that was already mentioned in the old CCNA 20125. Cisco have removed them. A lot of protocols actually, like RIP is not important, like BGP, EIGRP, FHRP with all its sub protocols, dynamic intervenor routing, VTP, a lot of protocols, as well as WAN and triple P protocols. All of them has been removed, but some of them are extremely important for any engineer to study, and they are still being used right now in more than 60 or 70% of the real networks currently. So it will be really annoying, or some kind of you'll be a bit of shy when you are certified as a Cisco associate engineer, but you have no idea how to apply HSRP, how to apply switch virtual interface, router on a stick, and even EIGRP and BGP actually. But the most common protocols that you will face in real networking right now is DHCP, HSRP, switch virtual interface, and router on a stick. For DHCP, it's already mentioned with all its sub features like snooping and relay in the course, and I've already implemented those. But for FHRP, which gives HSRP, VRRP, and GLBP, this one has been removed from the configuring matter. Switch virtual interface has already been removed. Yes, this one also. Router on a stick also have been removed. So what I did actually is that in this extra series, which is not the official course, this is the extra series, I have included those 3 protocols in every single lab, in those 3 labs that you'll see in the playlist of the Mega Lab series, the English Mega Lab series. You'll see that in each lab, one of those guys have been mentioned, configured, implemented, troubleshooted, and a lot of show commands for those protocols have been used, because it's really important to know. So this is an extra or a CCNA plus course or series, okay, which is only 3 videos. There was a plan for a 4th video, which was also very important for regarding access list and management, SSH, and so on. But for 2 reasons, which is number 1, for 2 reasons, I did not record I will not record the 4th video for the English series, and also I did not record that video in the Arabic series. Reason number 1 is that access list and management like SSH and login have already been implemented and configured in the original video, in the original series, I'm sorry. So I have shown all the commands and lab there. Reason number 2 is that I am spending ton of hours every day for creating the new and the upcoming, right now in June 2020, CCNP and CCIE in core exam, which has the number of 350-401. Okay, this is the CCNP and CCIE exam. Okay, this will be available almost in the 3rd week of June. It will also contain 7 chapters plus chapter 0 for an introduction and implementing or creating a real environment an emulation environment that we will use in the course. And it will be a very big and rich course, that because the in-core exam qualifies you for both the CCNP the CCNP Enterprise Certificate and the CCIE Enterprise Infrastructure Certificate. So yes, I have spent already ton of hours, and I will spend 10 ton of hours in the upcoming months or weeks to finish this course completely. Also in both languages, English and Arabic. So this is taking all my efforts. Okay. So starting with today's video, in video number 1 of this series, you will find a router on a stick was implemented in that. You can navigate the channel for Mega Lab number 1 in the Mega Lab playlist. In video number 2, you will find switch virtual interface and a lot of other protocols. Actually, the lab is not about router on a stick. No, it's about 8 protocols in one single lab. Okay, but one of them is router on a stick, which has not been mentioned in the original course. The second video lab also contains 8 or 7 protocols like DHCP, access list, switch virtual interface, maybe VLANs, spanning tree, modify some spanning tree, DHCPs, relay, and so on, OSPF, multi-area OSPF, ABRs, you see, all in one lab. So each lab takes from 90 up to 150 minutes, such thing. Yeah, it's 1.5 up to 2.5 hours. In today's video, we will do HSRP, of course, alongside with some other 6 protocols maybe. But the important guy here is HSRP, because it's very important for any engineer to know. And also FHRP protocols. I don't know, maybe no networks right now in the world works. Maybe 90% of networks in the world need FHRP. So you will need to know how FHRP is implemented. And one of the examples of FHRP is the HSRP. Okay. If you did not watch this video, you will see the HSRP implemented again in the upcoming CCNP course, because Cisco have removed the FHRP entirely from CCNA up to the CCNP from the configuring perspective. Okay, to start with today's video, We will connect two networks through two routers, a main and a backup router, and we will activate HSRP on both sides, and we will see what should happen. Okay, so I will start with today's network. Let me have some switches. Let's make them like 5 switches. Those are 5 switches. All of them goes to a single switch this way. That single switch will be connected to a multi-layer distribution switch. This multi-distribution switch will face all of those guys as a layer 2 and will face the core as a layer 3 device. Then I will need 2811 here. I will make a separate router, works and functions and operates only as a DHCP server. So this guy, even if it was a cheap router that I will buy maybe for $100 or $200 USDs, then it will be enough and it will not have like a glitch or a lag or a full CPU utilization, because I will operate only DHCP pools inside this router. Okay, there will be no VLANs, no complication in this network, because they are already done in the previous videos, and you should know how to do that in big and complicated labs or environments right now. Okay, currently. And also let me drag this a bit so I can draw some end devices. This distribution device will be connected to a router, so that the router will function a NAT, and there will be a backup router as well. Okay, so in this way, that will be in this way. My network will be connected to another network, which is like maybe google.com or cisco.com or whatever network, public network that's known for giving some services. That public network will be connected to let's have a switch here, and for that switch there will be 2 servers to that network that I would like to reach, each server giving different services. Okay, and for my network I will have 1, 2, 3 and 4, 5. Yeah, that will be enough devices. 5 end devices for my network. Yeah, just look like some distributed devices, makes no sense, but I will organize it in minutes. For this switch, let's connect all the switches together in a ring topology this way. So all of them are a ring topology right now. I would like some redundancy to be happened this way, so I will make sure if some port failures happens, then no problem. I would like to connect this guy here directly, and since 100 megabit per second for fast Ethernet ports are running here, I might receive, let me have a pen so I'll make it more logical, maybe all the end devices here and maybe some of end devices here as well, all of them are forwarding traffic to this root bridge, to this main or head of the ring switch, a traffic with about almost like 100 megabit per second, and as well from the other side another 100 or maybe another 80 or 70 megabits per second are coming from this way. So this device is total receiving more than 100 megabit per second, so it will not be logical or correct to design or to have a single fast Ethernet link that connects the head of the ring, or actually that represents the uplink of this device to the multi-layer switch or to the distribution switch. So from the design perspective, I will need an extra 100% 100 megabit per second link or cable, and I will bundle them, or I will aggregate these 2 cables together to create 200 megabit per second link. So that will be aggregation or bundling. So we will use Ether channel here. Okay. Later on, they will be connected main and backup this way and this way. This is what I will do right now. Okay. So just to clear the idea that why I will use Ether channel here and why I must use Ether channel. It's a must. You must use Ether channel. You must design your network to operate this way. Okay, so this is the uplink. That will be 200 a minimum. My distribution switch will be connected to the active router and to the standby router. The active router will be connected to the active router of this company. The standby will be connected, or the backup will be connected to the backup. and thus they will also have some HSRP or FHRP inside, depends on their protocol, but we will use HSRP today. And one last some few connections, and that is that. Okay, how about we just 1 2 3 here. I believe this will be enough because a big zoom is not really that preferred. Okay, let's make it this way. I will have my end device here, my end device here, and my end device this way. Let's make it look this organized, and those guys should be organized in this way. Okay, this will be a DHCP server that does only DHCP to give all those PCs a DHCP. Okay, and this is an uplink that is connected to a main and backup. Okay, let's leave it, put it this way. That should be good. Okay, so clearly what we will have today is a DHCP, definitely, because I will not use static IP addressing. I will need OSPF since I have multiple broadcast domains. I will use HSRP. Spanning tree is already enabled, but just in case this guy was not the root bridge, then I will make it the root bridge to make sure that the device or the switch that handles and controls the forwarding of all the traffic that runs inside this network will be the switch, the closest switch to the distribution layer. This is really important because the behavior of the traffic will be, if assuming that if this switch was the root bridge, then this PC will send its traffic to this one to this one, and this one, okay, maybe this way, maybe in this way, maybe in this way. All of those devices in the network will send their traffic to this guy, and later on this guy will resend the traffic all this way. So you can see that we might have some congestion in this link because some uploading traffic was going through those links to the root bridge, and then from that root bridge again to the core or to the distribution layer. This is not preferred from the design perspective. I would like to make this device a root bridge so that all traffic will be straightforward without doing a lot of paths or maybe traveling a lot of paths in the way. All of them should head to this one. If you were wondering that maybe you will have a bottleneck here, don't worry, we can like manipulate the costs in the CCNP exam or the CCNP course to divide some VLANs to go from this way and to manipulate other VLANs to go from this way. This will be either by using the PVST, RPVST Plus, or the MST. All of that will be configured in the CCNP course upcoming. Okay. So we will use spanning tree, as I said, DHCP, HSRP, Ether channel, OSPF, and NAT. Definitely, I will use NAT to translate the private subnets from this network to the public subnets that will go out. And to use NAT, I will use PAT. Very important because PAT has been removed from the CCNA course. So I will use PAT today here. I will show you the commands of PAT. And PAT requires access list. So you see, ton of protocols will be implemented today. 80 minutes already have been gone without starting implementing. Let's start. Okay. So number one, let me have a private network. I will prefer to use 10 today. So that will be 10.10.10.0/24 for my enterprise network here inside. So the DHCP pool will be of this guy. Okay. And also once they reach the 10 here, which is their gateway, then I will have this distribution guy will stay as layer 2. This will be a layer 2. Okay, this will be a layer 2. This aggregation device will not perform any layer 3 thing because HSRP will be configured in these routers. So this will be a layer 2 forwarding with Ether channel here. So once they reach this interface, I will have to advertise interfaces. So all the 10s are here. Let me show you something. What I mean is that network 10.10.10 something will cover all those devices, all this entire network. Okay, starting from this network to this network, it will be a different network. and it will be a third different network here. Okay, so I have 3 broadcast domains to use. Let's see, what should I use from this interface to this interface? Public IP addresses, of course, and those public IP addresses, let them be 10 is a private, 15 is not, 15.10.10.10. This way, no. 15.10.10. I will need to interface an IP address in this place, an IP address in this place. I will perform NAT on both routers. It will be identical config on both the devices. If NAT is here, the same command, NAT is here. Okay, and also let's make it /30. So this network and this network. Now /30 will be one IP address here, one IP address here. That will be enough, and we'll replicate it this way and this place. Okay, no problem. And also for this network, inside this network, I will have a private address. No, I will not have any private thing. The idea is that, like google.com, you reach the server of Google, which is 8.8.8.8. Let's make it /26. That will be enough. So we will use all the private IP addresses in this place, alongside with this place. And this devices also. No, 1 minute. That will make no sense. Yeah, I'm sorry. Yeah, that will be private. There will be another netting here. Okay, 10.0/27 will be enough. Yes, let's make some subnets to test our subnet mask skills. Okay. So 1 minute, let's try configuring the initial config, which is IP addressing and so on. Okay, so starting with the initial config, that will be 1 minute. I will treat that like a normal network when you reach any remote network, like you have your PC right now and you would like to ping 8.8.8.8, which is an IP address of a Google server in someplace in the world. So this is an IP address of a server, but it's a public IP address because we cannot pick the private IP address of that server. The reason is private IP address. I cannot know the private IP address of inside google.com. So I will need to make it public, definitely. So I will use another public network here inside this network, inside Google's maybe network as an example, so that I will not use NAT. So I will pair here with the routing protocol between the private and the public with NATing. And my private IP address will be NATed through the active router to become a public, and that public will go directly to communicate with the public IP address of the that server. This is the only way to achieve that. Okay, so there will be NAT on this device, there will be no NAT on this device, only routing protocol advertisement. Okay, so without further talking, talked a lot actually. Let's start by modifying this, and let's make it another public network. That should be 2010.10.0. That's a public IP address. Okay, so for my entire network, I will have DHCP. Let's start giving IP addresses to my network. If you would like to come this way. Okay, let's start with no. Enable config T. I'm sorry, terminal. And host name should be DHCP server. Thank you. I will have to assign an IP address here, so that will be interface fast Ethernet. Who disabled the interfaces? I did. So that will be preferences. Always show port labels. Yes, and port labels will not show correctly. That is unfortunate because of backtracer. This is unbelievable for backtracer. Okay, that will be which one? I will decide it myself. 1 minute. Fast Ethernet 01. Okay, thank you. Go again. So fast Ethernet 01. Interface fast Ethernet 00. I'm sorry. This interface, which is heading to the network, I have to give it an IP address, static IP address from my network, so that later I will give it the DHCP commands. So that will be IP address 10.10.10. Let's make it from the end to 50 with 250/24. Okay, no shutdown to enable it. That will be good. And let's start doing the DHCP commands. Okay, so IP DHCP. I'm sorry, why are you in this mode? IP DHCP pool. Let's create a pool. Let's call it for today's. That will be the III HSRP lab, and it will have the network of 10.10.10.0/24. And whenever you give someone or a device an IP address and a subnet, please also give them the gateway of 10.10.10.1, and this is very important. We will talk about that in minutes. Also, I would prefer to give them some DNS server that will be 1.1.1.1. That would be good. One last thing is to exclude the IP address of the gateway, because it will be given to the router, so that no other device will take the same IP address, to avoid the duplication of addresses. So excluded address will be 10.10.10.1, the gateway. Not only the gateway, because we will do HSRP today, and HSRP and any other FHRP protocol is all about simple idea of you have a real gateway IP address here, a real backup gateway IP address here. You will create a virtual router between them that resides in both the routers. That virtual router have a virtual IP address. That virtual IP address will be the real gateway for all your devices. Okay, so this virtual interface that does not exist will be 10.10.10.1. okay, but these two real existing devices will need also a real IP addresses. So I will give the active a .2, I will give the standby or the backup a .3. So these are three IP addresses that I will use in between these two routers. So I will need to exclude all these IP addresses, as well as the IP address of this interface. Of course, do not forget about that, because it's already used and assigned statically in this place, which is .250 or 250. Okay, so I will have to exclude 4 addresses, which will be all of those addresses. That would be good, and I believe I can write my config or save my config, because no further things are needed in this device. Okay, let's test our config. If this device will receive an IP address, subnet mask, DHCP, and DNS. Yep, 10.10.10.4, because 1, 2, 3, and 3 are excluded. Correct subnet mask, correct gateway and DNS, all of them. The second one, a DHCP request. Succeeded, thank you, successful. A third one, .6. Fourth, .7. And the fifth PC and final one will be .8 maybe. That will be randomly. .8. All of those 5 devices have acquired an IP subnet and a gateway. Gateways actually haven't been assigned yet, but inside your local network, your enterprise network, what you need to communicate end devices between switches is an IP address and a subnet mask. Okay, so let's test any of those devices. Let's see if you can ping 10.10.10.8, which is this one here, and the ping is successful. Okay, we have no problem. We can receive a reply from .8 itself, which is like this PC. Good, we are done. So my network have IP addresses. I will not configure VLANs today. You know how to do that. I have done ton of labs before about that. And the DHCP server is working good. DHCP server. Okay, this is the main switch that I would like to make sure that this one is the root bridge, so that all the requests come to this one before heading up. Okay, so let's make this device a root bridge. Okay, so that will be in this way. enable, configure terminal, the host name, I would like to call it the root switch, and show spanning tree. Maybe it's already the root bridge if we are lucky. No, because the root MAC address is this MAC address and my MAC address is this one. I don't know which one is this device actually, who is the root right now, but I know that I can go to this one through fast Ethernet 02. Okay, thanks to the topology, fast Ethernet 02 is not showing correctly because of the annoying pack tracer. But anyway, what I would like to make sure of is that I would like to make this device the root bridge, okay, manually. So configure terminal, spanning tree, priority. What is wrong with you? Spanning tree VLAN 1, which is the default VLAN that is regarding everything. I would like myself to make myself a root primary. Number 1. Enter. Okay. And let's check the command of show spanning tree again to verify if this command worked or not. And you can see that this bridge is the root. That's it. Done. And all my ports right now are designated. All the other ports are forwarding. Okay, that would be awesome. Let me save my commands or my config so far. So this is number 1. Okay, that would be good. Number 2, I believe in a few minutes this one should become green. This one should become root because it's facing the root bridge. So this is a designated port. This should be a root port. Okay. Number 2 is that I would like to make these two interfaces as Ether channel. Okay, thanks to these devices, or the numbering here is not showing which device is this. So let me try my luck and issue the command show CDP neighbors, because okay, that is brilliant. You can see that fast Ethernet 01 is connected to a 2960, so it's either this device or this device. Fast Ethernet 02 is also connected to fast 2960, which is one of these two. Fast Ethernet 03 is connected to a router, which is 2800, this one. So that leaves to me fast Ethernet 04 and 5 only, which they should be connected to this multi-layer switch. That is brilliant. Okay, so config T, interface range, fast Ethernet 04 and 5. I will make them an Ether channel using LAC-P. So channel, Ether channel, spanning tree, VLANs, DHCP, all of those are not new protocols. All of them have been discussed by details, implemented in more than one lab before in the original course. So you should review that course first. Okay, so channel group 1 mode active, and that is that. Exit, that is all I need. Another exit. And let me save my commands by typing right. Okay, my configs. Okay, from this way I would like to initially do the same. Okay, CLI, which interfaces are those? Let me see. No, enable, configure terminal. The host name will be main switch. Okay, exit. Let me try my luck and see if CDP will be good to me. Nothing is showing because these interfaces are negotiating and these interfaces are down. Okay, I will have to do something, and that something will be disconnect this interface, reconnect it on fast Ethernet 03. Disconnect this interface, reconnect it as fast Ethernet 04. So 3 and 4 should be configured as Ether channel from this side. I'm sorry, not from this side, but I'm doing 3 and 4. Oh, sorry, will be towarding the two routers. So 1 and 2 will definitely be toward these switches. Okay, so I'm sorry already that packtracer is doing that. That's because we should have enabled. I should have enabled the port labeling before I start building the labs or the devices. So thanks a lot for this software. But anyway. So configure terminal. From this side I will make these two ports, which are fast Ethernet 01 and 2 as Ether channel, So interface range fast Ethernet 0, 1 and 2, and if I was not mistaken, you will see both of them will become green in minutes or moments. Channel group 1 mode active also. You can make it passive if you would like. You see both of them are down. That's brilliant, then I'm correct. Exit. And I don't think that I will need any other thing to be configured from this way, because this device will remain a layer 2 device, so nothing is needed. Let's issue show ether channel summary and see. Good, very good. What I have is I have group number 1, which is that group number 1 has the name of PO1. It has the flag S. Capital S refers to a layer 2, and U, which is in use right now, it's using lag P. Fast Ethernet 01 has a flag of capital P, which is included in the port channel, as well as Fast Ethernet 02. That's very good. Okay, so a bit of fast forwarding. 1, 2, 3. Everything is green. Thank you very much. You can see that clearly. I believe no further things are needed right now. What's really needed right now is to give a gateway, configure a real gateway for these devices, and see if those devices will be able to reach their gateways. That gateway will be 10.10.10.2, .1, but let's see when will that be where will that be configured. Okay, so this will be the main router. I will make it the main R, and this should be the backup router, so that will be the backup router. And this way for my network. Let's start with the main router and let's see where will we head today. Okay, no, enable config T. The host name should be the main router of my network. Okay, so that will be network number 1 main R. Okay, you can name it whatever you like, whatever you want. Okay, so Fast Ethernet 00 is connected to the switch. This is a layer 2 switch, so Fast Ethernet 00 is connected through a layer 2 devices all the way to the end devices. So it will be their kind of gateway, okay, because it will not be a real gateway. I will tell you the reason why. Okay, config T. Okay, so interface Fast Ethernet 00. IP address will be 10.10.10.2/24 wake up exit for this interface. Okay, and I will give .3 for this interface. For anyone who have not watched chapter 4, when I had a separated video for only explaining the concepts of FHRP, which HSRP one of them. Why there is an HSRP? Because there is a global rule says that if you go with 2 routers, then you consider yourself you have 1 router, because at any moment you are threatened to lose one of them for any reason. High temperature, bad climate, high moisture content in the room, electric shock, software failure, hardware failure, cable disconnected, port disabled, anything that would cause your device to become down. So if you have one router, then you are null, you have no gateway, because you are threatened at any moment to lose your gateway and thus internet and connectivity to the world. And if you are happy because you will install 2 routers, a main and backup, don't really be happy, because actually you have 1, because the second will be threatened to be lost at any time. Yes, I'm not talking like negatively, because things happens. The most expensive routers in the world that will cost you more than $100,000 per router, they are threatened to be down at any moment for tens of reasons. Yes, believe that, I have been through that like in the past 3 years. This is real annoying, I know that. That's okay. So at least the minimum things that I can do for myself or for my network is at least to buy a backup router that have the same model and specification as the main router. And the next step will be, you have to give a gateway for those devices, and that gateway should be an IP address of the main or of the facing router interface. So if I gave them .2 as a gateway for those devices, and .2 was this interface, and this other interface cannot be the same at all. This will be dot 3. So when this one fails, the devices are still sending to dot 2 because their gateway is dot 2. I'll have to log into each end device in the network and manually change their gateway to be dot 3, so that devices will say, oh, we will start asking dot 3 from now on to reach the internet. Okay, are you convinced with this way, like logging to hundreds, tens, or hundreds or thousands of devices to change their gateway manually? Of course not. So you'll need a protocol that will do that dynamically instead of you doing that manually. That protocol is one of the FHRP protocols, which is either HSRP for Cisco only, VRRP open standard for any device, GLBP for Cisco only again, but with some extra features. Okay, so we are using HSRP today. The idea will be give dot 2 here, give dot 3 here, give dot 1 in both devices virtually, make dot 1 is the gateway of the devices. What will happen is that we will manually prefer this one to be the main router. Manually, we will make this one to be a backup router. You will see the commands in a few minutes. They are very simple, okay, and clear text. And let the network operate normally. So all the networks will always send to dot 1, thinking that dot 1 is here to reach the internet. Once this device goes down, another router will say, hey, I am also a dot 1. I'm also a 10.10.10.1. Send to me instead. Devices will start sending to this device in a matter of some milliseconds of losing. Okay, they will start to send to this device again. And we can also enable another command saying that whenever the real main router gets fixed and back operating normally in the network, make it handle the traffic again. Let's make this router a main one again and make this one goes back up again. You will see all the commands very simply in a few minutes, but this is all the idea of the FHRP, all the protocols. Okay, so starting with main router number 1, I have gave it an IP address of dot 2. Let's give the virtual IP address of dot 1 and enable HSRP. Okay, so this will be very simple commands. That will be interface fast Ethernet 00. This interface that I've just logged in and given a real IP address, I will give the virtual IP address of HSRP right here in the same place, using the commands of standby and specify a number, a group number. This is just a number, a numeric value, whatever number you would like from this range, to arrange or to recognize that those devices have this router as their main and this router as their backup. You can later on the same router create standby with another different group or another different network to make this router as their backup router while the other one as their main router. This manipulation will be done in detail in the CCNP course. Okay, so let's give it number 1 and let's give the virtual IP address of 10.10.10.1. okay, so this interface right now has a real IP address of dot 2, a virtual IP address of dot 1. That virtual IP address is the gateway of the network. Okay, and another command will be standby 1. Okay, I will need to assign a priority level to this router to manually make this router the main router. The reason is, by default, each router, when you enable HSRP, it has an HSRP priority built inside it, and that HSRP router or priority, you will see that it ranges from 0 to 255. If you did not specify this value, by default it's 100, okay, inside this router. Okay, sorry, by default it's, what's wrong with you, it's 100. So both the routers will by default become 100. So which one will be the main router? I will need to specify myself. So let's make it 120, so that I will make sure from now forever this router will always be the main router. Okay, so far I have 2 commands: standby 1 IP, standby 1 priority, and 1/3 and final command that I will need today will be standby 1 preempt. This command to enable preemption, that whenever this router fails, this one will be the main router. It will handle the scenario, but whenever later on when this router gets fixed, I would like this router to handle the network again, to become a primary router again. This feature will only be enabled by typing the command standby1 preempt, and that's it. 3 lines are needed only: standby IP, standby priority, standby preempt. That is that. Exit again, save your commands. Okay, let's move this window away for a few minutes. Let's go to the backup router and let's do the same with a different real IP address and a bit of different values regarding the HSRP. Okay, so enable config key host name, I'm sorry, 1 network 1, the backup router. Okay, so interface fast Ethernet 00, let's give it .3/24 and enable it. That would be good. And on the same router I will enable standby, the same group. It's extremely important, so that you will make this router the backup of that router, because both of them have the same standby number, group number, and both of them are connected through a layer 2. So both of them are or relies inside the same broadcast domain, in a single broadcast domain. So they are connected through a layer 2 device. That will be important. Okay, the virtual IP will be the same. .1, standby 1, the priority by default is 100 and the other device is 120. So definitely this one will become a backup, but just to make sure, let's make it 80 for further. Maybe in the future I will change this one without I pay attention. Okay, and standby 1 preempt should also be enabled in this device. And let's save my config and let me verify if what I have done so far is correct or not by delivering the command or issuing the command show standby. Okay, so fast Ethernet 00 is included in the HSRP in group number 1. Right now state is speak, so both the devices are still negotiating. It's not active, neither standby. So let's issue the command again, because this port is green. Let's see, it's still speak. The devices are still negotiating who should be the active, who should be the standby. This one should become standby if my config is correct. I can see that I have received a message right now. The message says that fast Ethernet 00 group 1 have become from speak to standby. It has been changed. Okay, clear the screen, show standby. You will see that right now it's standby. So this device right now is standby. The other device should be active. Okay, so the virtual IP address is this one. A virtual MAC address will automatically be generated. The active router is the router that's carrying this real IP address, which is this one. Preemption is enabled. Thank you. The standby router is the local router. So right now I am in the standby router. My priority is 80. By the way, it's configured. It's not the default. Okay, I really thank you. Let's compare it to the other one, to the other guy's config or the statistics, and let's see, show standby. Things are different here because it's active, the same virtual IP address. The active router is the local, so right now I am in the active router. Preemption is enabled. The standby router is the one that have .3 in it, and priority is 120. By the way, it's configured, it's not default. So how we will test that, I will show you in 1 minute. That will be log into whatever device you would like. Hit the command of ping -t is ping forever, and ping my default gateway. Let's see what will happen. There is a ping. I can reach my default gateway. That is good. It's continuing. Let's see for 1 minute what will happen if my real router goes down, dead. Okay, so let's have this router. Let's save everything. Let's see if I can, yes, shut it down. What will happen here? The gateway is dead. Okay, can we reach the gateway? No, it should be not. But if HSRP works, then few seconds after that. In the real life it's much faster than this way. Don't worry, we will not lose connectivity for more than 10 seconds this way. It will be milliseconds, and we can even manipulate that furthermore. Okay, this is timeout. Please, any news? Will this take a lot of time? Ah, that took a lot of time. Okay, so my main router is still down, but I can see that I have reachability to the gateway. Who is the gateway? It should be this device, because there is a message says that this device from standby it become active. Okay, so how about we re-enable our device, go to the CLI and wait for this device to boot up, and while it's booting up, let me use one thing, and that one thing will be bring this one here, and let's see what will happen after this device boots up. I can use fast forwarding. I can wait 1 minute. It's still pinging the backup one because this device is still loading. Okay, it's up, it's running. Let's see if the ports are up. Ports are negotiating. Okay, enable show standby. Listening. Okay, listening. Still listening. If preempt works, then this one will become active, not standby. Speaking. Okay, listening, speaking, and active at any moment unless I receive the message first. Still speaking. Still speaking. Devices are still amber. Yes, port is still amber, but the ping has not been down so far. It's still up. Still speaking. Any moment, please. Let me wait for the message of notification of the syslog saying that the device has become inactive, or at least standby, if I was wrong by configuring the preempt. But focusing on the ping, so far my network is still having net internet is still reaching the gateway, and the gateway should deal with the rest. Okay, there is a message said that it goes from standby to active, because it seems that the default behavior of HSRP making a router is passive, standby, unless HSRP was configured. So it was directly from speak to active, considering that standby is that. So yes, I did lose it for one timeout. Yep. So it's back active again. Okay, welcome back. So this router is back again. That will be good. And that is that for so far. Okay, so practicing or testing HSRP is now done for this network. HSRP is working normally on this network. That is good. Let's configure the second network and also configure HSRP in the second network and verify it, and after that I will connect both the networks using a routing protocol, a NAT, an access list, and have a final check. Okay, by disabling the router, of course, the main router, and see if this PC or any of those PC will be able to reach another server through the main and the backup device. Okay, so start with this network. Server number 1 will be from network 20. I'll do that statically, no need for the DHCP here. Let's make it dot 100. No, not 100. The subnet mask is /27. /27 gives us 32 IP address minus 2, 30 valid IP address. So I have from dot 1 to dot 30. I will do dot 21 and dot 22 for those guys. So dot 21 will be for this network. Yes, that will be 255, 255. 224 represents /27 for please, and my gateway will be 20.10.10.1 for sure. Okay, for the first server. The second server will be .22. This is how servers looks. Just a perfect image, not really. 20.10.10.22. 255s and 224, and let's go to, I'm sorry, yeah, I know, just 1 minute, just relax. 20.10.10.1, that will be good for so far. No need for a DNS really, because this is a DNS. I will behave it this way. The main router here will be this one, will also be a main router. Oh, you're really annoying. Okay, 2 main router satisfied, and 2 backup router. Okay, go ahead. This router. CLI? No. I'm sorry, which interfaces are those? Are they fast Ethernet 00? 1 minute. Reconnect that to 01. Reconnect that to 01. So that will be 01, 01 from this side. So I'll use it. So 00 is from this side. Okay, no problem. So config T, the host name will be 2 main-r, capital 1. Okay, start with interface fast Ethernet 01. This one is heading to this private network of that guy, which will be the IP address of 20.10.10.2, not .1. .1 will be the virtual for the HSRP. Okay, /27, very important. No shot. Virtual will be brilliant. Okay, so let's give an HSRP before leaving. Okay, so standby. Can I use standby 1 here? Of course, this is another network. Okay, so we can use the same number. It will not be duplicated with the other routers. They will not negotiate that. Don't worry, because this is a layer 3 port, so standby messages will not cross over this interface. So standby 1, the virtual IP will be 20.10.10.1, represents the gateway of the servers. Standby 1, priority, I will make it 120 for this main router. And standby 1, preempt is enabled. Okay, and write to save my config and leave. This way. The backup guy, come please. No, enable conft, the host name will be 2 backup interface fast Ethernet 01. Also regarding this topology, the IP address will be .3. I hope that you get the idea so far. Yep. No shot. Yes, that is enabled. Let us configure HSRP. Okay, standby 1, the virtual IP, which is 20.10.10.1. No subnet mask is needed. As you can see, standby 1, the priority, let's make it 80 also. You can leave it if you'd like. Standby 1, a preempt. Y, a D, no D, yep. And write, save my config, leave this device, a bit of fast forwarding, another fast forwarding, going again to this main router, and we can see the message says that this guy is inactive. Are you sure? Show standby. Yes, this device is active. The virtual IP address is this one, and preempt is enabled. I'm the active. The standby is that guy with this priority, as you can see. What should that mean? That should mean if one of the servers tried to reach its gateway because it wants to go to the internet later, so ping -t 20.10.10.1, we will receive a ping, and for whatever reason, if the main router, right, poorly goes down, this way, poor guy, it's down, I will lose the ping for a few seconds like we saw. Meanwhile, I'm sorry. Meanwhile, let's see if this guy will receive the message saying that it will become the active because it's standby. So far it's standby. Yep, that was very fast. It received a message already. Show standby. Okay, it's the active. Okay, so the backup, as you can see, the same thing we have just replicated to the second network. It's an active. This poor guy is still receiving timeout. It should be ping reply at any moment now. Waiting. You can see there is a reply. Thanks a lot. Okay, so we are good. Let's enable our good router again. Good. Hit the button. Enabled. A bit of fast forwarding. Another fast forwarding. One last to make sure that this one is active again. Is it CLI? Yes, it's active again. Okay, so this network separately inside it, within that network, this network number one, have their gateway, they can reach it good, have a backup router, everything is good. Okay, the second network as well is also good. Next, let's connect the two routers. Okay, so I will perform the IP addresses here. I will definitely need OSPF. I will do some ping between the routers and see if they can communicate together. Later on, I will do NAT, so I will make my routers be able to reach this one. And one last verification will be shut down the main routers and see if I will, okay, be able to reach that. Okay, so let's do that again. Okay, not again, for the first time. Okay, so OSPF here, OSPF on the backup. 4 routers will be configured for OSPF, IP addresses, and test the connectivity. Good. I hope that you did not get bored so far. Let's start the process. That will be config T. Interface, this is 0 and 0, so this will be fast Ethernet 01 and 01. So fast Ethernet 01, an IP add of 15.10.10.1.2 because they are mine, and I will give you .3 and .4. This is based on a contract that we assigned together to use public IP addresses between us. .1 /192 represents /26. Okay, no shut, no HSRP between those two. Okay, it will be a point-to-point link. Okay, exit. Let me advertise what I have. So I will advertise network private 10.10.10.0 to 55 area 0. You might be wondering, will you advertise network 15 in OSPF? Yes, I will do. It's a public IP address. Yes, I know. Why would you use an interior gateway protocol? Because BGP is not a simple protocol. It has been removed from the Ccna, so I will not use it here. I will use OSPF instead. Is that legal? Definitely. Both OSPF and EIGRP are IGPs, interior gateway protocols, but based on contracts that you sign with the opposite side, you can use external OSPF and external EIGRP. That will be done by using two features. The first will be called route redistribute, route redistribution or redistribute. The second will be route summarization, double M A R I Z or Z A T I O N. Okay, summarization. That is the two features that I should enable with OSPF in real life, not in the CCNA. Both of them are definitely CCNPs and CCIEs. Okay, but I will just use OSPF normally. I will advertise it normally, and you will see that the network will work great. No problems will be there. Okay, but this lab is not 100% real life. It's 90% real life because it will need extra features for OSPF to be used with external routing, or at least we can use BGP in the network. Okay, so the other network will be 15.10.10.0. That will be 192, so that will be 63 here /26, also area 0. So I have advertised my right, my left. Thanks a lot. And the same commands will definitely be duplicated here. If there was a DHCP server on this device, I will have to copy the commands of this device and paste it here, because if this one goes down, then another server should become a backup and continue giving IP addresses. but I have isolated DHCP inside the network to get a relief of that. Okay, so I have an IP address here, an OSPF connecting together. How about you wait me for a few minutes? I will configure this guy. 1 minute. Let's have OSPF connectivity. Enable. Configure terminal. Interface fast Ethernet. Since 01 is here, then this will be 00. IP add, that will be .3, 15, 10, 10, 3, 192. Good. And how about I advertise OSPF? 15.10.10.0 and also their enterprise address. How much will that be? Any help? Yeah. And so show IP OSPF neighbor. Two-way. This will take 2 years. OSPF is very slow, and backtracer is even slower. I can do fast forwarding. Please, please, please. I will be very annoying person. Do that, please. No, I will do fast forwarding. And twice. Okay. And you can see by fast forwarding you receive the full. Okay, don't worry, in real life OSPF is not that slow at all. It's about not less more than 5 seconds. Okay, but EHRP is about 1 second. Okay, so I have OSPF connectivity. What does that mean? This should mean that without a NAT, by using the identical and perfect behavior of backtracer, this PC should ping the server right now without a NAT. Okay, because backtracer does not really understand those things. So ping 20.10.10.21. I will receive a ping. You see, I will receive a ping, but this is not what's happening in real life. I should translate the private IP address of 10 to make it a 15 on this edge and forward the packet. Okay, but the good thing or the good side is that I have network reachability correct from this broadcast domain through the second broadcast domain up to the third and final and further or farthest broadcast domain reaching the server. Good. Okay, let's go back to the backup side. Also configure OSPF and do some ping between those devices. Okay, or at least ping this IP address. Let's see if we can reach it this way. Okay, so the backup router, it's a standby poor guy. So I will go to fast Ethernet 01 here. Okay, give an IP address and also give OSPF. Interface fast Ethernet 01. 01. Why am I missing this? Yeah, 01, I'm sorry. Okay, and IP address will be .3, 2, 15, 10, 10, 2, 2 to 4, no shot, exit, router OSPF 1, network the 10s, and also, I'm sorry, 255, yeah, I'm sorry, 255, and also network 15, I give a mistake in subnet mask here. I will have to delete that. This is /27. The interface is /26. I'm sorry. I will correct that in 1 minute. It's /26 192. So it will be 63. Area 0. That was very fast. I will have some comments after publishing this video saying that, sir, you have typed network 15 10 10 10. This wildcard mask, and with no error you have typed enter. No, I did type 0 at the same moment that this message popped up, this annoying message saying that the neighbor adjacency of 10 is established, of 15 is established. It means that through this network, this way, with this guy, through this, okay. But My 0 is here. Okay, I did type 0 at the same moment it was shifted below. Okay, so the command was accepted. If I did type the command this way, there will always be a message saying the incomplete command, but because I have typed it correctly and the 0 was here, so it was accepted and taken by the router. Okay, so let me just allow me to correct this one. That should be 192. That was fast Ethernet 01. So exit interface fast Ethernet 01. How to delete a mistaken IP address will be no IP address, and then no, the buffer cannot handle a lot. IP address will be 15 10 10 2 192. Thank you, thank you, and thank you. Right. Okay, hide it. Go to the backup guy. Let's do the same. Advertise to networks with an IP address on 00. It's a standby. Okay. That will be .4. No shot. Q. Exit. Router OSPF1. The network will be the 15. 63. I will receive an adjacency message in a few seconds. 20 /27, and we are done. Okay, leave that. A bit of fast forwarding. Let's see if I can reach the IP address. This one actually, if routing works correctly. This will be 20.10.10.3. Okay, ping 20.10.10.3 indicates success, so success rate is 5 on 5. Okay, good. What do I have so far? Main connectivity, backup connectivity, full reachability, but really I need a NAT. One last thing is the only thing is that I need a NAT, and I will use PAT because I have multiple devices in my network. All of them I will translate them virtually to the public address of this interface. I will also configure NAT on this interface, so when this one goes down, okay, the backup will operate normally, we'll have OSPF normally, we'll have also NAT and access list to translate the private to public and go outside to the network, okay, to the internet. So NAT and PAT, both of them requires a standard access list to be configured. In that access list, you need to only permit your network, your enterprise network, which is 10 dot something, so that every single PC or a device, whatever type of device, inside 10.10.10. something /24 will be allowed to have its address translated to a public IP address and fly away to the internet. Okay, so on the main router, I will have an enter, an exit. Okay, access list number 1, it's a standard access list, no need for extended. Only permit my network of 10.10.10.0 that has this wildcard mask. That's it, a single command. Okay, so let's configure PAT. What's the difference between PAT and NAT, static NAT? One keyword that will be added to the command, to the end of the command of the static NAT. How do we configure static NAT? It will be IP NAT for whom? For the inside. I will specify who the inside in minutes, and that inside is sourced from access list number 1. Do them a NAT to NAT them or translate the addresses of access list number 1 of the inside network to the address of fast Ethernet interface fast Ethernet 01, this interface. Right now, if I just hit enter, this is a static NAT that will take only the first request from the network, from private IP address, and translate it to a public IP address, and all the other IP addresses will not be able to reach the internet because this is a static NAT. How to do that? By typing overload. Just add overload, hit enter. This is no longer a static NAT command. This is a NAT overload, which is no electricity, which is a PAT command. And PAT is one too many, 1 to 65,000 IP address. So all of those guys will be able to reach the internet using a virtual public IP address starting from now on. Okay, so and let me try reachability and connectivity to any server there. Ping again. There should be a ping. Okay, there is a ping so far, and let's see if that ping did hit the command. It will not. It will not. Yes, because I have forgot something. Show NAT translations. Why? Show NAT translations. Show IP NAT translations. No translations happen. The reason why is that I have just informed him to do NAT for the inside, but who's the inside? My mistake, my bad. I forgot to specify this interface as an inside NAT and this interface as an outside NAT. That's very important. Okay, so config t interface fast ethernet 00 IP NAT in exit interface, I'm sorry, fast ethernet 01 IP NAT outside, and save my commands, do the ping again and see if that will hit anything. There is a ping, there is a reachability. Let's see how this PC did. Why did I say how loudly? Okay, let's see how did this PC reach the internet by issuing the command of show IPNAT translations. Okay, so inside local I have an IP address of a private that globally was translated to 15 that reached out 20 dot something. Translation is successful. Okay, that is brilliant. I will have to replicate the same commands, the same specific commands, okay, on this backup router. So just in case this one fails, the backup will do so. Okay, go again, do access list, do NAT, specify inside and outside, and that's it. So access list number one, permit 10.10.10.0 and IP NAT for the inside guys that are sourced in access list number one. Make it a fast Ethernet IP address of 01. Never forget the overload, please. Done. Okay, so interface fast Ethernet 00 is an IP NAT in. Interface fast Ethernet 01 is an IP NAT out. And right, and that is everything we need to configure so far in the network. What will happen is that I have a network, I have my network collapsed into a switch, my switch connects me to my edge router, that edge router has a routing protocol, has NAT, will translate my private IP addresses to public IP address, go through the internet to another company far away that have different public IP addresses and reach their services, whether this server or this server, whatever you like. What happens when this guy or this link, one of those links that affects this path, what happens if one of those links goes down? Then the backup should take that. There is one thing that we will need to discuss right now, which is right now in the Ccna study and in this specific lab, if I had this interface went down, which represents the gateway for my network should go through the backup. Am I correct? That will be correct, because all of the end devices will sense that 10.10.10.1 is gone, but later they will find 10.10.10.1 here. Okay, so they will send the request this way and it will reach this way because there is NAT and OSPF, no problem. They are active, not passive. They will reach this place, they will reach here, they will reach the server. What will the server do? the server will reply to you, and the first step for the server will be its gateway, which is 20.10.10.1. Okay, but right now in this situation, 20.10.10.1 is this router because it's working, and as long as it's working, it's active. Okay, HSRP says that this one is active, so this is .1. So your packet will have this path sent, but the reply will be from this path to this router. This router will send it to this router. This router has a problem here, so your reply will stop. So this is a disaster. You have lost your internet because your upload is working normally. Your download is stuck in this place. So scenario number 1 will make HSRP useless because only this interface went down. Okay. Scenario number 2 will be if this interface went down, okay, or this interface, one of this, if this link went down, okay, if this link went down, we know what happens. If this link goes down, what will happen? What will happen is that my network sees that this interface is up and running, so it will send to this network and the packet will stop here. And if only the other network also try to communicate to you, then the other network will also see that their gateway is up and running, so they will send their packet to this gateway. But I'm sorry, the link between them is down. HSRP will not sense that, will have no idea, it will not indicate that failure, not at all. Okay, so scenario number 1 and 2, both of them make HSRP looks useless. Scenario number 3 and the final one will be if this link went down from this side or this side, okay, but this link went down, then you will send, then these two devices will make this router as their active router, so their gateway will be this gateway, this one, okay, but your request to the internet will go this way, and finally this way, and it will drop here because this link is down. So these servers will not sense any request from you, and thus they will not reply you. And even if one of those try to communicate you for whatever reason, they will communicate you through this path, and you will reply them, I'm sorry for this lag, you will reply them through this path. So scenario number 1, 2 and 3, all the three of them makes HSRP useless when you have multiple networks using HSRP. So what's the idea? When will HSRP work? HSRP will work when you have your two routers, both of them are connected to one router here. That will work. Okay, but all the networks in the world right now, all the companies uses FHRP. So you will definitely see this topology. The solution will be to enable some very CCNP and CCIE specific config, which will be IP Service Level Agreement Protocol, IPSLA. IPSLA is a specific protocol that has a tool that's called an IPSLA track or tracker, and the job of the tracker will be you will install some sensors on these two interfaces and some sensors on these two, as well as these four interfaces below as well, saying that do always sense the health status of this interface or this link. Once it goes down, do you shut down this interface as well? You see? And from this side as well, this device says whenever one of these two goes down, make the other one goes down. So what you'll have, whenever one of these three links goes down for whatever reason, because of any of the 6 ports you can see, 1, 2, 3, 4, 5 and 6, then the entire path will go down. And when the entire path is down, then this one will sense itself to become active, this one will make itself or indicate itself to become active, and you'll have this redundant path completely up and running as an active path. So you will need definitely an IPSLA tracker to enable this very important feature to operate. Okay, for today we cannot do that because we will need an IPSLA, but what we can do, really what I can do right now, is only to shut down these two routers, so that will disable all those 3 links and see if the ping will continue to operate all the way. Okay, so this PC let's change it and ping this server. So that will be ping -t 20.10.10.22, and that should ping forever. And let's see if we can have a reply right now. Will be timed for the first one, unfortunately, but for the rest it will be a reply. Okay, this is taking 2 years. Come on. Yep. Okay, this will continue pinging. I will not stop that. Leave it to ping all the time. Okay, so how is that pinging reaching this device through these two routers? How about we disable them both and see what happens? Okay, so let me save my config and shut down or disable, turn off this router. Let me save my config and physically down, go back to the PC. Now we will have some timeouts, but later we should have a reply. All the entire backup path should operate as active and active, and we will verify it. Okay. I don't know if the IPSLA is all about discussion or configuring or troubleshooting in the CCNP in-core course, but if it was configuring, then I will do the same lab there later then. In that one. Okay, it will not be Backtracer at all. It will be EVE and G, different topology and different program and software for emulating. But I will use IPSLA. IPSLA is not even compatible with ESE. Yes, thank you. It's not supported in the Backtracer as well, the IPSLA. But I will do HSRP and IPSLA, and let's see, by disabling only one single interface of those 6, we should have or emulate the same behavior like disabling the 2 routers. Right now I have a ping. How did that ping occur? By having this guy becoming an active one. Let's see. Show standby. Okay, up, it's an active one. Thank you. And this other guy is also active. We can see the message. We can verify it by ourselves. Show standby. You can see that the state is active. Okay, so thankfully that's good. Let me save my config before I forget. For this one, yep. Let me save my config here. No problem. And let's enable those devices to go back again. I'm sorry. Power up and power up. And that is that. I should not save those. I have a config here. Let me save it while those devices are operating. I have configured priority here. Let me save it to make sure that this will always be the one. I have DHCP. Let me save it. I did not configure those switches. Those are saved by default. So why are you still red? Yep. In one fast forwarding, everything is almost green. The second one is good. And let me see if this one is active again. Yes, this one is active again. This one is active again. And today's lab is done. I hope that you did enjoy that. I hope that my English, awful English accent was clear to you. I'm really working on that. What we have used today was DHCP first, spanning tree priority, no VLANs were configured, an ether channel between these two guys, OSPF to connect them together, an access list for NAT, which was PAT. Let's make a PAT here. And last but not least, the main hero of today's series, which is HSRP. Have I forgot something? I believe not. I believe not. Yes. 1, 2, 3, 4, 5, 6, 7 protocols in one single lab. I hope that all of those will clear to you, were clear to you. I hope that you did make big use of this lab, enjoyed it, did not waste a lot of time by practicing that. I hope that you all will implement and verify your labs And you can always comment down below the video. There is a Facebook page which is Facebook/III networking, III networking, my Facebook page, Instagram/III networking, LinkedIn/Sajjad Ghafouri. Okay, so I'm available wherever you want, whenever you want. Just ask whatever you would like. This is the last technical thing that I will ever record for the CCNA 200-301. The upcoming will be the CCNP Encore. Okay, with the exception of that, I will always record the CCNA 200-301 exam preparation, because those will continue to upgrade forever. Every 2 to 3 months will be an update to that series. Okay, so thanks again for watching. I really hope to see you in the upcoming videos, in the upcoming series of the CCNP. It will be incredible. Okay, goodbye.